Hello. Today we're going to be working on adding and subtracting radicals. So to get us going here, we're going to take a look at stuff that we have done in the past. We're going to be combining like terms with variables first. So we're going to do x plus x. When we add those together, we end up getting 2x. So you notice all we do is we combine the coefficients. We do 1 plus 1. For the next one, we have all of these different variables. The first thing we do is we actually figure out which ones we can combine and which ones we can't combine. For instance, we can add all of the x's together and the y's together, but we can't add the x's and the y's together to get one answer. So if we add 2x to 1x, we get 3x. If we do negative 3y plus 1y, we get negative 2y. And our answer is just those two written separately. So the whole idea with radicals is it's going to follow these rules. In order to add radicals, they have to be like terms. So for instance, the square root of 5 and the square root of 3, they're not like terms. Those would be like trying to add an x and a y together. But if you had 2 root 5 and 3 root 5, those are like terms. So these two could be added together. Once you figure out which ones you can add together, you're going to add just like you add your variables, meaning the only thing that changes is the leading coefficient. So you add the numbers out in front, but you leave the term itself alone. So let's go ahead and take a look at that. So example A shows this. We can see that they are like terms because they both have root 2. So to add these together, we have 3 of the root 2's, and we are adding 5 more of the root 2's. So what we do is we add the coefficients to get an 8, but we leave the root 2 alone because that is kind of like our variable. Okay, so add the numbers out in front and leave the radical alone. So let's go ahead and take a look at examples 1 and 2 down below. So example 1 here, notice how it has root 5 and root 5. They are like terms because the root 5's are the same, which means we're going to take the coefficients, negative 2 and a positive 1, and we're going to add those together. If there's nothing in front of the radical, it's like up here when there was nothing in front of the x, we said that there was a 1 there. So it's going to be the same idea. So we're doing negative 2 plus 1 to get negative 1. And then our term itself is root 5. So negative 1 root 5 or negative root 5. For the next one, all of these are like terms. You see the 10, 10, and 10. So we can go ahead and add all of these together. So we're going to go through and look at our coefficients, and we're going to combine those. So we have 4 plus 1, which is 5, minus 7, which is negative 2. And all of our terms were root 10. So we add the coefficients and leave the radical alone. But sometimes, looking at example 3 over here and example B, they aren't like terms. So don't fall into the trap here. Some people, like for example 3, they would look at it and say the square root of 68. That is not how we add radicals. It's like saying x plus y equals xy. We just can't do that. So you have to ask yourself, though, even though these aren't alike, is there anything that breaks down? So the 27 here is 9 times 3, and 9 is 3 times 3. So the pair of 3's would come out in front, and you would be left with 1 3. So this problem really is saying 6 root 3 minus 3 root 3. And by rewriting it in its simplest form, now that we see that now they're like terms, now we can combine them together. So we're going to do 6 minus 3 to get 3. And our term here is root 3. because that's what our radical was. So let's go ahead and take a look at example 3. We're going to do it that same way. You look at it and you say, nope, can't add them together, but I can simplify them. So you're going to take 18 and you're going to break it down. It's 9 times 2. 9 is 3 times 3. So 18 has a 3 on the outside and then a 2 on the inside. And we're going to do the same thing with 50. So it's 25 times 2. 25 is 5 times 5. Since there's nothing out in front, we just write the 5, and then the 2 is left on the inside. And at this point, now these are like terms. So 3 root 2 plus 5 root 2, they both have the same radical. So we know it's going to be root 2. And so we add the coefficients. 3 plus 5 gives us 8. So our answer for this one would be 8 root 2. So that's the idea here. So adding radicals, you add the coefficients if you have like terms. Sometimes you have to simplify things first in order to do this. So let's go ahead and try a couple more practice problems. We'll do 4 through 7 here together. So looking at this, number 4, they're both root 3s. So we're going to take 5 and add it to 6 to get 11 root 3. Number 5, we're doing root 7 minus 9 root 7. They are like terms, so we're going to go ahead and do the leading coefficients. There's a 1 implied here, so we're going to do 1 minus 9, which is negative 8, root 7. Number 6, these are not like terms, so we need to see if we can make them like terms by simplifying. And sometimes nothing can work, so you just leave it as is. But for this one, the 27 does break down. 27 has a pair of 3's in it. So I'm going to write 4 root 3 minus, the pair of 3's comes out, and we're left with 1 3 on the inside. At which point, now these are like terms. So 4 root 3 minus 3 root 3 would be 1 root 3, or you could write that as just root 3. So let's look at number 7. 2 root 3 doesn't break down anymore because of the 3 on the inside. The 75 does break down. That is 25 times 3. So I'm going to take out a pair of 5's, but when I take them out, I can't forget I already had a 4 on the outside there. So when I take out that pair of 5's, I'm going to multiply it by that 4 to get a 20 on the outside and a 3 under the radical. So this is saying 2 root 3 plus 20 root 3. So these are now like terms. We're going to do 22 root 3. Okay. So I would like you to pause the video and try numbers 8 and 9 on your own. So break everything down and then figure out what you can combine together. When you're done with that, unpause the video to check it out and see how you did. Okay, before we reveal the final answer, let's take a look at number 8. Let's make sure that root 24 turned into 2 root 6. Root 96 should be 6 root 6. And then your last term did not change. So then once you get it to this point, we're going to do 2 minus 6, which is negative 4, plus 1, which is negative 3 root 6. We can add them all together because they were all root 6, so we can combine all of those. So let's take a look at number 9. The first one didn't change. This 3 root 8 becomes 6 root 2. Double check that you didn't write 2 root 2 because of this number out in front. And then 2 root 32 becomes 8 root 2. When you bring out the 2 and the 2, and there's already that 2 out in front. So just double check that real quick. Then we can combine all of these because they're all root 2's. So 6 minus 6 is 0. And then we have plus 8. So it's going to be 8, oops, not root 8, but 8 root 2 rather. Okay, so far everything has ended up being like terms. You might get cases like number 10 here, 5 root 7 plus 3 root 11. This is like saying 5x plus 3y. The x and the y are different. The root 7 and the root 11 are different. So if that's the case, sometimes you just can't do anything. Like this is the simplest form. I cannot add them, they're not like terms, and nothing else simplifies, and that's okay. Sometimes for number 11, parts of this simplify, but other parts don't. So once again, you have to identify like terms. So 6 root 3 has another radical to combine with, but 4 root 2 does not. So in this case, what we'll do is 6 root 3 plus 1 root 3 to get 7 root 3. And then our other term would be 4 root 2. So you just write them out separately, and you don't end up combining them at the very end because it's root 3 and root 2. You only combine the ones that are alike. So for 12 and 13, all of these are different, but looking at them, they all break down. So take a moment, we're going to have you pause the video again, break down every single one of these, and then come back to talk about how we can combine them. So let's go ahead and take a look at number 12. We have 3 root 2 plus 5 root 2 plus 3 root 3. So looking at this, after we break everything down, only the root 2's will combine together. So we're going to do 3 plus 5 to get 8 root 2, then plus 3 root 3. That would be our final simplified answer. For number 13, let's go ahead and check each of these terms. The first one should be 6 root 5 because of the 2 out in front, then 2 root 3, then minus 6 root 5, and then minus 3 root 3. So for this, we actually have two sets of like terms. We have the 6 root 5 and the negative 6 root 5. We also have the 2 root 3 and the negative 3 root 3. So when we do 6 root 5 minus 6 root 5, those undo each other. 6 minus 6 is 0, so they cancel each other out. It's like saying 3x minus 3x. Those would undo each other. So then we have 2 root 3 minus 3 root 3. So 2 minus 3 is negative 1 root 3 or negative root 3. So thank you very much for listening. I hope this helped. Let me know if you have any questions on anything.